If you'll let me introduce myself, my name is David Marino. I am staff at FACET, the Faculty Academic Center of Excellence at Towson. And part of what we do, apart from instructional design, overall supporting faculty teaching, is we've also gotten into emerging technology. And this semester, Ryan Murray from the EMF department has started with us. He will be my co-presenter today. He specializes in virtual reality, and he'll be talking a little bit later on about some free programs that he uses to incorporate 3D models. So our workshop today is called Photogrammetry, and we'll go over what photogrammetry is, but we want to make the workshop as interactive as possible. So the major application that we're going to be talking about today is called Clone, and I'm going to post the links to Clone on the chat. You're welcome to download the app and install it. We're going to be talking about it in more detail later. But while we get the workshops going, you can download it, and if you also have access to a printer, you can also let me see the chat. If you have access to the printer, you can also, thank you, Ryan. You can also print the mat. The mat looks like this. It's something you can print straight from your computer, or so I have one. We have a larger printer in our office, so this is why it's so big. You can print it as small as a normal size piece of paper. The bigger piece of paper that you can print, the larger the object you can scan. And so later on, I'll be scanning this rock or something else. So if you wanna follow along, you can click on those links and download the application to your cell phone, or or print that mat. So today we're going to be going over what photogrammetry is, how it's used, and basically photogrammetry is just using pictures to make a 3D file. And you can see what another professor, please let me know if you can see this. Ryan, can you see the 3D model? Okay, yeah, so you can see this is an example of what another professor did a few semesters back using Clone. And it's a bit of a complicated, even though it's just an egg-shaped thing. As a political science professor, that's why he had a toy of Putin. But it was a little bit more complicated than it looks, because it's a shiny reflective object, and that's why you can kind of see the lights. So you can do some powerful things with something simple that you can download to your phone. So we're gonna do some Clone demonstrations, and then we're gonna talk a little bit how you can actually bring it into your teaching, into your course, using free software, free websites, and how to embed them into your Blackboard course. And then Ryan's going to talk a little bit about Unity and Blender, which are, again, free applications to manipulate some of the 3D objects later on. Then I'll talk about a different software that's not free, but we at the office have access to, called Metashape. And I'm going to click that example just to see what we can do. And this is an example of a scan that we did using that software. So this is not the one through the iPhone or iPad. This one's a little bit more complicated using DSLR cameras. But I just wanted to show you an example of how detailed a scan can get. And this is a very complicated model because of the overhangs and stuff like that. I just wanted to show you an example of what those 3D objects may look like at the end. So photogrammetry. So the way I like to introduce photogrammetry to people who've never heard of it is, if you think about the Matrix, you know, remember the shot where Neo is dodging the bullets and the camera goes around him. So the way they did that is they just put more than 100 cameras around him, and then they use different shots to make it seem like he's moving, but they're going around him. They made him almost like a 3D object. So you can see in that screenshot of the production, all those cameras that were set up around him. So photogrammetry is basically the same idea, except that you only really need one camera. So you are the one that goes around the object. So think about it that way. Instead of having to use 130 cameras, you just use one camera and you take 130 different shots at different angles. So why would we use 3D models in education? We can look at the constructivist theory about how using more senses increases the amount of retention. So if a person is touching something, so these 3D scans can be manipulated on an iPad, on an iPhone. If you're able to, even if you're on a computer, click, zoom, turn around, zoom out, zoom in, it just increases the amount of senses that are being used to look at an object, and it should theoretically increase retention. So I have here, for example, a model of the brain. So just a quick story, I'm taking some classes right now at UB, and the class that I'm taking right now is supposed to be in person, and we were supposed to dissect a brain, which would have been amazing. But obviously we can't do that. And what the professor's been doing is just showing us drawings of the brain. But if you can't actually get access to a brain to dissect it, perhaps the next best thing would be able to access a free model. And this one takes a while because it's so complicated, and be able to see the inside of the brain in a way that you wouldn't be able to do in a dissection. So perhaps it's the next best thing to an actual physical object, that you can zoom in, look at the different parts of the brain, zoom out, rotate, and as a professor, you can annotate different areas to explain what they are. So there goes the thalamus. So that's what we can do with the 3D model. And just another example of photogrammetry. This commercial was from about a year and a half ago. I'm just gonna click a couple of minutes of it.
Right now, historical sites are disappearing, but artificial intelligence can help us bring history back to life.
If you don't know where you come from, you don't know where you go. We use Microsoft AI to help us reproduce historical places.
I need to make it possible because it's so important to do it.
To recreate the site, we had to stitch hundreds of pictures, one by one.
With Microsoft Artificial Intelligence,
we are able to stitch hundreds of thousands of pictures in one night.
So, so this guy is doing the same thing that we'll be doing today, but a much bigger scale. He's using a massive monopod, putting his DSLR camera on it, and then flying a drone around architectural sites and able to reproduce a 3D rendering of those sites simply by using cameras and then software. So there's different ways of capturing. We have 3D scanners. Our office actually has a 3D scanner, and it has built-in software that stitches, like he was talking about, stitches different pictures together automatically. So it takes a lot of the work out of the way. You can do very good renderings of 3D objects using things like your iPhone or your Android device nowadays. The processors in the telephones are good enough to do some rendering. And then drones, like the guy who was just flying the drone. And then other applications on the iPhone. Here's another example of a face scanner that you can reproduce just using your iPhone. So this is the process. So first you have to capture it using something like a DSLR camera, an iPad or an iPhone like we're doing today, or something more complex like a drone if you want to get big. And then you process it, bring it into different software. And most of the software we're going to talk about today is free and accessible, and we'll have a list of those software. So if you're interested in looking into it, you can download it and play around with it for free. And then I'm going to talk about some software that's not free but we have access to. And then finally, how to publish it. And this is where it gets cool. You can upload files to free websites and then distribute it that way, so people can access the link. If someone accesses it using their iPads or something, they can manipulate with their hands. And you can even 3D print stuff. So I'll talk a little bit about how we flew our drone later on, but then show you an example of a 3D print that we were able to do. So there's different media that you can ultimately distribute it and publish it. So instructional applications. We have a lot of examples, and ultimately we will post these slides so that anyone who's interested in different examples can click on it and view different disciplines. But anyone wants to see anything in particular? So we have different examples. But if anyone wants to see one of these, please speak up and let me know. If not, I'm gonna click on the Bolex example, just because I was an EMF grad, just to show you another example of a 3D scan. Okay, so anthropology, history. Okay, sounds good. I'll click on those next. And so Ryan can tell you, he's a professor at EMF, that some students only have access to cameras for a week out of the semester. So, you know, you might have a little bit of access to it during class periods here and there, but typically to film your project, you only have 1 week. So I would have loved to have access to something like this and study up on the different buttons and functions of a camera.
And especially during COVID, you know, students may never have seen or touched or had this demonstrated in person before before they have to borrow it themselves.
And you can see how minute the details can get. So I'm going to, 1 second, I'm just gonna click away from that. So folks said they wanted to see anthropology. So anthropology, I'm not sure if I have a good example of that right now, but anthropology maybe, and we might also tick the box for history, archaeology. So here you have a 3D scan of a fossil, of a skeleton, and basically the same concept applies, where you just take a lot of different pictures from different angles, and then you can zoom in, view it from very close up. You can see the bottom it thinks it's hollow because obviously we can't take pictures from underneath that certain model, but this is really detailed for a free website. Yes. And let me see if anything else. Oh yeah, so here, again, here's another example of history. Here is a 3D model. This one takes a little while to load just because it has so many different pictures and triangles that were put together to make this 3D model. Here's a castle in France. You know, this is the next best thing to actually being able to be there, especially now during COVID. Like Ryan said, there's things that we can't do right now, and you can see it in different ways that you would never be able to see, even if you visited there. And you can see the detail. Okay, whoops. Okay, I think I geeked out there too much. So show another quick video just to show you how the process works with a software developer explaining how they use photogrammetry. And I'm generally going to play a couple minutes so you can see.
But it's worth mentioning that because photogrammetry does afford you this quality versus speed ratio, the quality versus speed ratio is very high, you can get creative. You don't have to worry about kind of playing around. So this was kind of a fun, I would say, experiment, except we actually ended up using this. So we went to the hardware store and kind of fashioned ourselves a close approximation to an AT-AT foot. We got a tub of flour and stamped it into the flour, scanned it in, got got a result like this. And to be honest, in less than a day, we had this prototype working. This is the absolute very first test. So like, you see popping and things like that. So this isn't what we ship with, but just really great to show how you can kind of prototype high quality results and techniques without.
So you can see that even software developers making a game for Star Wars use photogrammetry to speed the process of creating 3D environments. And he goes on down here at the bottom to talk a little bit about how much faster it is to create assets using photography and photogrammetry than it is to just make things from scratch. So it speeds up the process, and it's being used worldwide by complex software developers. But we're going to talk a little bit about what you can do at home. So I'm not sure if anyone was able to print out that mat that looks like this and download the Clone app. If you haven't, don't worry, we're going to record this and you can follow along later on. But what I'm going to do is I'm going to do a quick live demonstration of what that looks like. So what that means is that there is a chance that I will mess up. So be ready for that. But I'm going to do a quick demonstration using some stuff that I had here around the office. Would people like to see me scan a paperweight or a rock? Please post it on the chat. Majority will win. Okay, we got rock. All right, rock it is. Sounds good. Okay, so I'm gonna stop sharing my my screen so I can share my iPad. Okay, so I'm gonna open up the Clone app. Here you go. Here's some other models that we've worked on in the past. And I'm gonna try to go slowly, but please let me know if you need me to repeat a part. So at the bottom of the Clone app, bottom right, there is a plus button to start a new project. I'm gonna click on that. And here you should be able to see what my desk looks like and my mat. And my mat's a lot bigger than some of the mats that you'll be able to print at home. But you can see as soon as it sees all four corners, it makes this virtual dome, and that's the world that I can capture. And as long as I can see all four corners, I'll be able to make a 3D model. I also made myself this turntable. It's a 3D printed turntable, so it cost me maybe $1 in materials. And you don't have to use a turntable, it just makes it a little easier for me using this bigger board. And the whole idea with this is that you want to have the model be as steady as possible while you're going around the mat. So I'm not going to go around the mat. I'm going to use a turntable, and hopefully it will make it easier for me to keep it steady. On the top right, there's a record button, which lets the app know that I'm ready to start capturing some scans. And let's see. Whenever you move out of view of all four corners, the app will make the globe, the little sphere, disappear, and that'll let you know it's not capturing. So as long as you can see the four corners, you should be able to capture. I'm going to hit record, and then I'm going to start spinning it, and you can see it starts letting me know which parts are already captured. And if you look at the bottom right of my screen, you'll see that it starts compiling those photos, because what it's doing is taking pictures. It starts compiling those photos and building a 3D object right here on the iPad. So it doesn't take a supercomputer to make this. You could use it using an iPad or an iPhone or an Android device. And you can see at the bottom right, it's already starting to build something. And I'm going kind of fast right now, just for the sake of time. You want to take your time on this so that you can keep the model, the object, as steady as possible. And you can see on the bottom right, it's starting to build that rock. I'm still working on it. Still working on it. All right, I'm going to go a little faster. So it might not be the best model, and you do have to be a little patient in the beginning. And I'm going to do the top standing up just to get this done faster. Whoop, wrong way. Okay, there you go. So now the iPad itself and the app clone is processing it, and there it goes. It gives me a rendering of it, and then right now I'm manipulating it with my finger. And you can see the bottom is blurry because obviously I didn't see it. The app lets you do a second scan of an object, and then it stitches both the top and the bottom together. If you can see there's a small button, a blue button at the top right, that lets you do that second scan. I won't do it just for the sake of time because it's basically the same concept. It's just that I flip the rock upside down and rescan it. So I'm not going to do this. I'm not going to do the bottom, but you can see that I was able to do this just using my iPad. And then if I click on the bottom right, I have my finished. I can edit some things. I can mess with the contrast, with the texture, with the color, but I can also export it as well if I need to. And another cool thing that this app has an augmented reality setting. So you let it know where a flat surface is, and it's having a hard time seeing a flat surface just because this is a glass table. There you go. Once I click it, I can go around it and see what that rock looks like. And here's an actual rock next to it, a little blurry. So if I make this a little bigger, you might not be able to tell which one is the real one, which one's not the real one. So it does a pretty good job of creating an artificial object just using the processing power of the iPad. You can then, which is very important, export it to something that you can distribute to your students or your colleagues. I'm going to click on this share button, and here you have different options. Object files here in the middle. Object STF files are files that you can bring over to a 3D printer and 3D print. So I could clone this, pun intended, and have a 3D printed version of this rock. Obviously, it won't be the same color, but then you can paint it. You can make a replica of it, and it also lets you export file types that can be shareable on the iPhone. USDZ is the file type that iPhones use, so you can text message this to a friend. They'll be able to pull it up as augmented reality wherever they are. But for our purposes, I'm gonna do Sketchfab, and I'll talk a little bit more about Sketchfab later. I'm gonna call this new rock. I'm gonna say nature. Okay, and I've already signed in to Sketchfab on Clone, just because I didn't want to take up the time of showing you how to log in and all that. It's just a matter of signing up for a Sketchfab account and then logging into Clone using Sketchfab. So you can see it's been updated to uploaded to Sketchfab. So that is the demonstration on the iPad. I'm going to switch back to the computer so I can talk a little bit more about how to distribute that model. Any questions so far? If not, that's totally fine. Okay, I'm going to share my screen. Okay, so I'm gonna talk a little about Sketchfab, how to annotate it, as in put notes on the model, and then ultimately how to embed that into Blackboard. So I have my Sketchfab account, sketchfab.com. The accounts are free. They do have a limit on how many uploads you can do each month. I think that might actually be the last one that I can do for this month. But I'm gonna reload and see if the rock, here you go. Here's the new rock model that I just created. So now it's already live on the web. I know it's the new rock because it doesn't have a bottom to it. And I can do some editing to it. You can mess around from where the sun is coming from. Oh, sorry. Edit 3D settings is what I want to do. I can mess around where the sun's coming from. I can mess around with the background. But I think what would be useful for teaching is annotating. So if there's a certain section of the rock that you want to emphasize, or any other kind of model, you double click on it and you can give it a title, you can give a description, you can even add pictures, more detailed pictures. If you upgrade, of course, if you upgrade to Sketchfab Plus, I'm not sure if it's called Sketchfab Plus, but whatever their premium account is, you can add audio, so you can actually lecture about a certain section of the rock. So here you go, I'm gonna call this one the crease of the rock or something. And then I'm just gonna type whatever there. And here you have an annotated message to the students. I'm gonna hit save settings. I'm gonna exit out of there. And there you go, it has my note that I wrote on the rock. I'm gonna go down to embed here in Sketchfab. And this is the part where it looks a little daunting because you start seeing code. It's actually not too difficult. I'm gonna do an iframe embed code copy and paste. So you see I have iframe, and I'm gonna keep it to the aspect ratio that they have here. When I click on down here, it copies to the clipboard. So it already does a copy part of the paste. And then I'm gonna bring it over to Blackboard. I'm gonna hit build content, and I'm just gonna do it as if it was a normal item. I'm gonna give it a name. I'm gonna call it new rock. And then this is the part that looks a little daunting again and tricky. I'm gonna hit the HTML option so I can paste code into it. So you can see that code that looked a little daunting. All I did was just copy all that code and then paste it in the HTML section of the content area in Blackboard. So HTML, copy and paste. I'm gonna hit submit. That's gonna be all at the bottom. But there you go, it's within Blackboard. And students don't even have to click away from Blackboard. It's right there for them to access and manipulate within the course. So there aren't any special codes or special websites that they have to go to. They can embed it right there, or you can embed it right there and have them access it right there. So that is Clone, and bringing something that you can do from an iPad with a physical object using something that you can print at home, the mat, and then bring it straight into your class. And obviously it takes a little bit of practice in the beginning to get what you're looking for, but it just goes to show the power of the new tablets and iPhones that you can do this straight from your house. And that is the Clone demonstration and embedding it into Blackboard. Now Ryan's going to talk a little bit about using other software that's free and how he's used that software to get objects and then manipulate them a little bit. So I'm going to hit stop share here and let Ryan take over.
Hey everybody. So as if you couldn't set me up any better, Cynthia, in the chat, we had a couple of questions. One was, can you send the 3D model to a 3D printer? And absolutely you can. And I think David's going to show us a 3D printed Smith Hall or one of the buildings on campus, right? In a moment. But then Cynthia asked, has any art museums 3D scanned objects, paintings and sculptures and what have you? And I answered in the chat, but I want to use it as a segue here. Absolutely, they have. And let me show you this, just screenshots from this piece of software called the VR Museum of Fine Art. Okay, so I think that's the right screen, right? I've got a Google image search up, right, David?
Yep, I can see that.
Okay, cool. I've got two monitors and sometimes I'm like, wait, which one did I share? So check it out. These are 3D scans. And I think that's a Bernini sculpture, or like, you know, you got a Pietà, you've got, these are like what we're looking at here are 3D scans that you can walk around in VR in a VR headset and see, you know, these beautifully high resolution 3D scans of kind of art canon, not just sculpture, though sculpture looks really good in 3D scan, but they also have the Mona Lisa and Birth of Venus and Water Lilies is upstairs in the second floor. Some things that you would never be able to get very close to if you went to see them for real, but you can walk right up on them and you can see the paint brush strokes. I mean, it's like, it's not just a JPEG of the thing. It's like even the paintings have, you can get right up on them and see the texture. So it's not falsified, it's literally a scan of the actual object. Now, the reason that is a good segue is because we can do a pretty passable version of that going from photo scans to VR using free software. And I want to show you how I've done it with undergrads right here at Towson. So this is sort of a cut down demo from a larger, maybe like 20-minute long demo that I gave to my students in a virtual reality media production class. So I'm using this piece of software called Metashape, and I went out in my backyard and took about 100 pictures with my digital camera of this Fisher-Price car. You know, my son's toy car. So you download Metashape, it's free, and you dump all these pictures into it. I'm gonna go quickly because I'm not really necessarily trying to teach you the in and outs of Metashape right now, but I just wanna demonstrate like this is what you would do. Cool thing about Metashape is it has its whole kind of like process down here where you would change settings, but it's also pretty smart and you don't actually have to change any of the settings. The defaults are pretty good. So if you don't know what you're doing, you can just hit the big green start button and it basically works. Now, I then export the thing and bring it into another piece of free software called Blender. This is available for Mac or PC, and Blender is a fully featured 3D modeling program. Now, believe me, Blender is thorough. It's a heavy-duty program. It would take a lot of years to master it. But in terms of what I'm about to do in it, it's fairly quick. What's going on here is we're looking bird's eye view at like as much of my backyard as the camera saw. And this car. Now, the problem is I'm trying to not just look at this thing on Sketchfab, but I want it to become ultimately part of a virtual world that's going to run as an interactive piece of software, like a video game, but in a virtual reality headset. Do you see all these little dots? Just hundreds and hundreds and millions of little vertices. There's too many of them. No computer would be able to deal with this and process it all in real time in virtual reality headsets. So we got to get rid of all that stuff. So in this quick demonstration, I show my students how to highlight, delete the trash, and then you end up with something a lot closer to the object. But even here, you can see all of this detail. These are all polygons, you know, millions and millions of triangles that are making up this object. And it's too much for a game engine to process. So the other great thing about Blender is it has this tool on the right, one of many. The one I'm grabbing is called Decimate, which will cut down the polygon count. And so there's just a slider, and you're trying to pull it down until you visibly notice quality loss, and then you just pull it a little back up from that. So in this example, I was able to cut down to about 10% of the original polygons, like 90% of them are gone. You know, we went from 10 million to 1 million or something like that, which is really good. And so then this was the kind of final result. Now, it's a little sketchy, you know, there's some scuzz, of course, but with enough care in how many photos you take and from what angles, you can get a pretty convincing model. Now, here was the ultimate purpose of what I was trying to show my undergrads. This is yet a third free program called Unity, which is a video game design engine where you can do layout in 3D space. You can also do graphical interactivity programming, and also like straight up code programming in C# if that's your bag. But what's cool about this is not only can you make video games in it and 3D worlds, but you can also make virtual reality experiences. So what I was doing in this class was showing them how they could take a large scale object with free software, make it into a 3D model without having to know how to be a 3D modeler, and then drop it into the VR surreal room we were creating as a kind of project experience together. So here's the room that we had built little by little in each tutorial, you know, showing them how to create one thing or other. And then this was our photogrammetry object dropped into that room. Then this is a demo of what it looks like, you know, kind of in a mock-up headset. So you can walk all around it, cast light on it. It's an object like any other in the 3D simulation. So that's essentially the same process, and in fact, with the same software that this VR Museum of Fine Art was made. It was also made with Unity. The only real difference is it leaned on the actual museums to do the scans. A lot of world-class museums provide free 3D scans of some of their collection. I know the Smithsonian does, for example. So that's sort of my quick, you know, intro to a workflow that's entirely free software where you could take large-scale objects, bring them into a virtual world, and then output software that could be interactive on an Oculus headset or a Vive or any of these sort of computer-based tethered headset experiences.
And you used just your mobile phone to take those pictures of that toy?
In that case, it was a Canon DSLR, not a particularly high-end one. It was a pretty good one about 5 years ago. I think it was a Canon 60D. I might have paid $600 for it back when I bought it, and now it's like, it's been passed by, you know, it's obsolete now. So, but yeah, decent quality, but not impossible, you know, the kind of thing you might have available if you're at all into photography. But you can do it with your iPhone as well. The only downside with mobile phones is with photogrammetry, you'd really like to not end up with any motion blur. And sometimes mobile phones, it can be easier to end up with motion blur because you're not able to change all the manual settings to make sure your frame is really fast.
Yeah, there are ways to get your phone to be steady, and I was gonna show that next. I'm gonna share my screen if that's all right. All right. So Ryan talked about Mushroom, Blender, and Unity, all free software. I'm going to show you an example of Metashape, which is not a free software. There is an education level and then a professional level. But basically it does the same, it uses the same concept of pictures. And I'm going to show you a project that I worked on scanning a camera, and I used my iPhone for this. And what I did is I set up the iPhone on a tripod, put it underneath a light with a green background so I could cut out all the background. And you can see again, it kind of uses that matrix looking thing where it looks like there's 100 cameras around it, where in fact, there's just one camera that I took a bunch of pictures of. And I also took pictures of the bottom. You can see that I really concentrated on the lenses because it's a really difficult model to do overhangs, and especially when it's shiny. So I actually have the camera here in my office, and now I have a digital version of it if I ever wanna share it with anyone, or in case I lose my camera, I have at least a digital version of it. And you get pretty good detail just using your iPhone. And the reason I wanted to mention Metashape is because we have access to the software. If there is an object that you may want to create that's a little complex, right? You might not be able to do it with clone, or it's not working with the mat, or it might be too big for the mat. We have access to the software, and we also have the expertise with creating objects. So if you ever want to collaborate with Facet, please email us at facet@towson.edu. We also have an actual 3D scanner. I'm not sure if you can see all of it in the camera, but this is a really nice tool because it already has the lenses and the colors calibrated. It has it stationary, so it's as still as possible, and the turntable is automatic, so you don't actually have to turn it. So the whole idea with it is you can create very high detail renderings of objects. So if you want to collaborate, please let us know. We'll take most of the legwork on that. Finally, just to kind of wrap it all up, I wanted to mention a little bit about drones. So we showed you how you can use your iPhone, you can use your iPad to create something very small. You can also scale it up to the point where you fly a drone, and you can get basically the same idea. You know, instead of a small rock, you just do an entire building. You just use a camera that happens to fly as well. So here I have a 3D model of Stevens Hall. We flew about a year and a half ago, just before the construction of the new science building. So you can see they're starting to bring in all the construction equipment in there. But this is a 3D model of Stevens Hall. And same simple concept. It's pictures stitched together to make a 3D world with pretty good detail. And this, again, can be brought into a virtual world, kind of like Ryan was talking about using Unity, can be seen in a headset. So the concept is not too difficult. And as we mentioned, it's doable from home. And ultimately, like we mentioned, we can use the exact same file to do something like a 3D print. And again, I'm not sure how much you can see this in the video, but this is a 3D print of Stevens Hall that we used using the exact same model, using the same process that we did for getting the 3D the digital object. We can now create a miniature clone of the same thing. So it has a lot of applications. If there's something that's in the lab, something that's precious or expensive, instead of giving access to a lot of people, and to the point where it might be broken, you can clone it and do a practice version of it, or give people access to it digitally, just to get them access to it. So that's it. We talked about photogrammetry. We talked about how it can be used in the class. We practiced it on clone. I know that it was probably impossible to do this or difficult to do this at home. But we'll provide the video, and if you want to practice again, we showed how to incorporate it into Blackboard, and then we talked about professional equipment and software and free software. And so ultimately, we're going to let you know about other events coming up soon involving emerging technology. We have an event later on this month where Ryan's going to go deeper into Unity, which he talked about very briefly today, and then ultimately editing virtual reality video using Adobe Premiere. So any questions? So I'm not sure if I can see the chat. Okay, what program was the drone photogrammetry made as well? So we used the same software that we did for this camera, Metashape, Agisoft Metashape, which is kind of the industry leader right now when it comes to photogrammetry. There are other companies that make subscription-based cloud rendering software. This one's pretty good. So Cynthia, yes, we would like to offer this hands-on perhaps in the spring, depending on how things look with the school opening up again. So I'm hoping that we can do a lot more interactive things. We have a lot of plans to do virtual reality demonstrations. We hope to do more hands-on things like this once we can be open again.
One nice thing is short of this Metashape, everything else we demoed here today is free. And so if you have a smartphone and a printer, you can try Clone with a Q yourself now if you're not busy this afternoon, and see how it works for you. Now the 3D printer part, that's something that Facet would be able to support in a time when we can get physical people back together. Right, David?
Yeah, I actually was given permission to take 2 3D printers home, so I am doing some 3D printing at home. If you do make a clone at home and then can get me the file, we could make replicas of an object. So it is possible, even though we're not really on campus, we can do something like that. And to answer your question, Cynthia, about the programs, we're going to provide the slides to everyone that attended today, so that you can have a list of the software and also the links to it as well. I think all of them are linked. No, so one last thing before everyone heads out, and I do appreciate you taking the time. I'm gonna stop sharing my screen and I'm gonna post on the chat a link to a survey. If you could please fill it out. It's a quick anonymous 5 or 6 question survey. So it's very quick. If you don't mind, it's in the chat. If you don't mind clicking on that link and filling out the survey on your way out, I really appreciate it.
And I'm actually throwing together in the chat right now links to the free programs we discussed.
Okay, sounds good. Thank you, Ryan.
Absolutely.
All right, I'm going to stop recording the presentation and just thank everyone for taking the time out of your day to join us today, and please be on the lookout for more events from us.